All right. Good morning, Trisha, Michael, Therese, Ayesa, Zaira, and David. So, kumusta naman, guys? I hope you were able to watch the video recordings for the lectures for the lecture session last Tuesday. Kasi hindi ko na sila i-discuss in details. All right. So, but before we proceed, do you guys have any questions or clarificatory, or if you want to clarify some things from the video? Also, there are two parts. The video has two parts, okay? So, actually, hindi pala two parts. Dalawang videos yon. Yung isa will cover starting density property of the rationals in R. Tapos yung second ay hanggang doon sa, or until before isolated points, all right? So, yung pangalawang video, siguro a good portion of it, maybe half or more, ay parang review ng previous, last few topics in the previous video. So, kaya kahit siya ay 1 hour, 20 minutes in total, medyo mga 1 hour lang siya kung tatanggalin niyo yung review topics. But I guess having a refresher is very good. Tapos, kakaiba yung pagkakaputol ng mga lectures ko last semester. So, kaya merong ganung reviews sa simula. All right? And you know me, I usually start the class, first 10 minutes is devoted for what was done in the previous session. Okay? So, before we proceed, any questions or clarifications about the topics discussed in the video? Though I will run through each of them briefly, pero hindi ko nadadaanan yung mga proofs. We'll look at the results and probably some of the examples para lang ma-refresh kayo. Kasi yung iba sa kanila gagamitin natin in our discussion today. All right? So, no reactions? Everything's going well? Okay, so I'll assume that is the case. So just let me know otherwise. Okay. So, para nga pala dun sa iba, especially those who come in after I start sharing my screen, there's a glitch in MS Teams, and apparently it's still happening nowadays. So, kung pumasok kayo sa meeting and then you don't see my screen, just let me know via chat or unmute yourself para ma-restart ko yung screen sharing because it would be hard to just listen to what I'm saying without seeing what's on the textbook or seeing what I'm writing. Okay? So medyo mahirap na parang podcast lang tayo. So maganda yung may visual aid. Okay? And don't mind restarting the screen share para hindi kayo masyadong mahirapan. Sayang kasi yung pag-attend nyo ng session. Okay? So, tapos papanoorin nyo rin naman later yung recording, which is good, pero sayang yung pag-attend nyo live. Okay? All right. So if there are no other concerns, before we proceed, pala, I already graded homework number 2, so make sure take a look at my comments there, and then if you have some questions, just let me know. And yeah, take note of the comments and the annotations I wrote para hindi niyo na siya ulitin dun sa mga susunod na homeworks, right? And one thing that I noticed is a good number of you probably either forgot how to solve inequalities or had been very careless in writing the solution. Luckily, solving inequalities is not the star of homework number 2. So hindi ko na minusan yung mga may kulang na parts, alright? Dun sa pagsosolve ng inequality, hindi ko na hinanapan ng detalye kasi hindi yun yung focus ng homework problem, all right? But I don't know, siguro nakalimutan niyo kung paano magsulat ng tamang solution ng inequality because let's see. Because for instance, there I think you need to solve the inequality 10 root x minus x greater than 0, okay? And then some of you did algebraic manipulations and ended up with x times 100 minus x, if I'm not mistaken, greater than 0. So nakarating sila dyan. And then right after this, they just concluded that x belongs to the open interval 0 to 100. Okay? Now, I don't know where they got that. Okay? So, pero hindi ko na hinanapan ng explanation because probably this is too basic for you. All right? So, um, kaya hindi nyo na nilagay. Tapos yung iba, nag-conclude na lang na x is less than 100. And then, idinugsong na lang na x must be greater than 0 because merong square root kung saan nakapaloob si x. Which makes sense. Pero remember, pagka nagsasolve tayo ng nonlinear inequalities, gumagawa pa tayo ng sign table. Kung babalik tayo dun sa factored form niya, ito yung equivalent notion niya, right? And definitely x must be greater than 0. What we did in elementary algebra, we did a sign chart, right? We made a sign chart para dun sa mga critical numbers. Yung mga critical numbers ay x equals 0, which are the roots of basically each of the factors here. Okay? And then 100 minus x equals 100. Tapos titingnan natin yung behavior ng product all over these intervals, right? So kukunin mo yung sign ni x, sign ng 100 minus x, tapos yung sign ng product, x times 100 minus x. Tapos titingnan mo kung kailan positive. Sa mga intervals yan, siya ay positive. And then you will see that nagpa-positive lang siya dun sa open interval 0 to 100. Of course, you can completely disregard this case because again, we don't allow x's to be negative kasi meron kang square root dito. So I don't know, siguro na-overlook lang or you thought na hindi naman mahalaga yung pagsasolve ng inequality dun sa homework kaya hindi nyo na nilagay yung detalye. But yeah, just a reminder, ganito sinosolve yung mga nonlinear inequalities. All right? Then what else? I remembered something. Hindi ko lang maalala. Hindi. Naisip ko siya kanina pero hindi ko siya maalala ngayon. Hold on. Give me 30 seconds. Okay. Now, dun sa pagkuha ng supremum at saka infimum nung set na to, right? Remember the set given to you is a set of all x's that satisfy the said inequality, right? Yung iba, ang kinuhanan ng supremum at saka infimum ay yung set na to. Ang kinunan nila ay yung set ng mga 10 square root of x minus x na greater than 0. Remember, this is the set that I ask you to consider. Okay? So dahil ito yung kailangan yung hanapan ng supremum at infimum, hinahanapan mo ng supremum at infimum yung mga x's. Hindi yung value ng 10 root x minus x. Magkaiba itong set na ito. Etong set na to, tawagin natin itong set A, at saka yung set na to, 10 root x minus x such that x is greater than 0. Right? And then, dapat positive din nga pala ito. So perhaps siguro lagay ko na rin to rito. Okay? Magkaiba tong set A at saka si set B. Si set A, ang laman niya ay mga x's such that ano yung criteria para yung isang real number x ay mapasama dun sa set x. Dapat yung 10 root x minus x ay greater than 0. So ang hinahanapan natin ng supremum kay A ay yung mga x's. Alright? Now, some of you mistook that for finding the supremum and infimum for these guys. Okay? Magkaiba yung dalawang set na yan. Yung set B, siya naman yung set ng mga 10 root x minus x such that this guy is positive. Okay? So, kung ito yung binigay kong set, ang hanapan mo ng supremum at saka infimum ay itong set na to. Set ng mga numbers na ganito yung form. Alright? However, since the given is the set A, then ang hanapan nyo ng supremum at infimum ay yung mga set X. Alright? So I hope that is clear. Any reactions, questions about that? So how was that homework? Or ayaw nyo nang pag-usapan yung homework na yan? Okay? So again, if you have questions, just let me. Yes, David?
So I think it's been 4 years since I last solved an inequality kaya nakalimutan ko na rin paano.
Okay, right. So yeah, that's fine. Luckily, hindi ganun ka-komplikado yung inequality at madali siyang i-visualize, alright? So, and then another good thing for you guys is hindi naman to algebra course. So hindi ko kayo tinetest kung kaya niyo mag-solve ng inequalities. Minsan pakiramdam na lang or instinct, okay lang. Pero yeah, just be careful because there might be a time where I give you a very complicated inequality na hindi na siya nasosolve ng kapaan lang or instinct lang, katulad ng ginamit nyo sa previous homework, kailanganin nyo na talaga mag-solve gumawa ng isang sign chart para dun sa inequality na yan. All right. So I hope those things are clear. So let's move on. Okay. Now, ano yung mga tiningnan natin last time? Okay. Or ano yung mga pinapanood ko kayo dun sa dalawang videos? Okay. So we still look at some consequences of the completeness of the set of real numbers. Okay. So ano yung mga direct consequences or direct implications? Ano yung mga properties na kaya nating i-attribute kasi complete yung set ng mga real numbers? Last week, we ended up with the Archimedean principle. All right. Ibig sabihin, kahit ano pang epsilon, na mas any positive epsilon, however small, there will always exist a natural number such that 1 over n is less than epsilon. All right? So lagi tayong may nakikita pang mas maliit na number, mas maliit na positive number sa kahit na ano pang maliit na positive number. And one way to get that smaller positive number is looking at the quotient 1 over n for some natural number n. And that is thanks to another consequence na unbounded above yung set of natural numbers. Okay? So na-prove pa natin siya last week. So ang tinigilan natin last time ay yung density property ng Q in R. Oh, by the way guys, nag-update pa ba yung screen ko on your end? Oh, mukhang tumigil na yung screen sharing ko. Hold on. Oh, nakikita nyo pa? Sorry. Inano ko siya. The-restart ko. Hindi ko kasi siya nakikitang gumagalaw dun sa monitor ko. So probably mabagal lang yung internet dun sa laptop ko. Okay, there we go. So the density property of Q and R. In a nutshell, this tells us that between any two real number, laging merong isang rational number. Kaya sabi natin siya ay dense. Yung pagkaka-pack o pagkaka-arrange ng mga real numbers sa real number line ay napaka-dense. Meaning pag kumuha ka ng isang napakaliit na portion of it, alright, say two real numbers that are very close to each other, there is another real number in between them. And actually, it's not just any real number. We are sure that between any two real numbers, there is a rational number between them. Kaya sabi natin, laging may nakapaningit na rational number sa dalawang elements ni R. Okay? Laging merong rational number sa pagitan ng dalawang real numbers. Dahil, so yun yung tinatawag natin na density property. Siyempre, hindi papadaig yung irrational numbers. So we also have a density property for the irrationals in R. Ibig sabihin, sa pagitan ng dalawang real number, meron pa rin nag-exist na isang irrational number. Okay? So, kaya hindi ka mauubusan ng mga rationals at mga irrational numbers. Kasi if you take two arbitrary real numbers that are distinct, then you are sure that there exists at least one rational and at least one irrational number in between them. Okay? And it can be shown using a recursive argument na hindi lang isa yung rational sa pagitan ng dalawa na yon. There would be infinitely many rational numbers between two real numbers. And the same thing goes for the irrational numbers. Ito yung sabi ng ilan yung classmates last time na para siyang bisection method. Kasi paulit-ulit ka makakakuha ng rational sa isang paliit na interval. So ganun din sa Q complement. So ito yung tinatawag natin na density property. Napakasiksik ng pagkakalista o pagkakalinya ng mga real number sa real number line. Okay? And I guess in the video, I proved theorem 1.10 and left theorem 1.11 as an exercise. I'm still thinking about the proof of theorem 1.11, pero medyo komplikado yung naiisip kong proof. So I haven't searched for an either proof. So that's why medyo aloof ako na ibigay siya as an exercise or as a homework. So if you can find a nice proof, kindly share that with me kasi hindi ko siya ma-prove ng maiksi lang o ng madali. So laging may trick na kailangan akong gawin which seems to be unnatural to do. All right. So if you find a nice proof for theorem 1.11, kindly share that with me, okay? So there are also some exercises following these two theorems. So kindly check them out, okay? Okay. Now, dun sa video, pinag-usapan din doon yung open and closed sets. So basically, this is what we call the point set topology in the set of real numbers. So maybe a show of hands, sino sa inyo yung nag-take na ng topology? I think sa math lang yata siya required. Math 138 nga ba yun? Noong time ko kasi hindi pa required yung topology. So probably you are familiar with this definitions. Okay, wala ba nagre-react or mabagal lang talaga yung internet ko, hindi ko nakikita yung reactions?
Ako sir, hindi ko po nagtitake.
Okay, thank you, Lyra. Yeah. All right, so dahil walang gustong umamin na nag-take niya ng 138, so I'll assume that you haven't taken 138 and that's fine. Because again, meron tayong meta-axiom of ignorance dito. Kailangan kong i-discuss lahat ng kailangan natin. And anyway, Math 138 is not a prerequisite to the course, right? So sinimulan yung discussion ng open and closed sets sa isang epsilon neighborhood. Okay? Pag sinabi mo yung mga terms sa analysis at topology, meron silang dahilan kung bakit sila yung tinawag. Tapos medyo funny yung mga mathematician na yung kanilang mga terms na ginagamit will have some clever, some cunning, and some intuitive sense to it kung bakit nila yung tinawag na gano'n. Halimbawa, epsilon neighborhood. Pag sinabi mong neighborhood, mga kapitbahay, mga magkakalapit ng bahay. Alright? So tapos si epsilon, sabi natin, this is a notion for very small numbers. Right? So epsilon neighborhood, ibig sabihin, ito yung mga magkakalapit na points. So pag sinabi mong epsilon neighborhood ng isang number A, ibig sabihin, isa siya intuitively, isa siyang set ng mga points na super malalapit kay A. Right? And true enough, that is formalized in definition 1.7. Pag sinabi mong epsilon neighborhood, siya yung set na ito. Okay? So we denote it by capital B. Kasi sa multidimensional topology, open ball or mga balls yung tawag sa kanila. So kaya ni-restrict natin siya or inadapt natin siya for the reals, right? So this is the epsilon neighborhood, subscript yung epsilon, centered at A. Neighborhood siya ni A. So ibig sabihin, ito ay mga numbers na malalapit kay A, right? So gaano kalalapit, that will be determined by the number epsilon that you gave, right? So basically, this is the set of all x's that are within epsilon units away from A. O kolektahin mo lang lahat ng mga kapitbahay ni A. Paano mo i-define yung pagiging kapitbahay? Dapat hindi sila lumalampas ng epsilon, yung layo nila from each other. And in the set of real numbers in one dimension, all right, siya lang yung open interval 1 minus epsilon hanggang 1 plus epsilon. Okay? So, yeah, so we can interchangeably use the term epsilon neighborhood centered at A with the open interval around A with radius epsilon. Okay? Tapos siningnan nyo yung interior point. Kailan natin masasabi ng isang point A ay interior sa isang set A? Well, it is interior to a set A if and only if if and only if there exists an epsilon neighborhood around A that is a subset of the set O. Medyo may typo yata rito. Yeah, there's a typo here. Hindi dapat A, ito dapat ay O. Kinurek ko ba ito dun sa video? Or pinangatawanan ko? Baka nakalimutan ko siyang i-correct. Yes, Michael?
Sir, iba po ata yung definition po na nasa video po para mas maikli po siya. Kaya hindi ko po ma-compare yung nandito po pati nasa video.
Okay. Thank you, Michael. Yeah. Kasi ang kwento nga pala nito, kaya naubos yung oras ko, kwento ako ng kwento, ano? Para icebreaker na rin, ano? So, last minute na bigay sa akin yung Math 155, yung pangalawang section last semester. So, I asked Sir Edu to lend me his materials. Tapos meron akong mga ibang binago. Minsan nagdi-discuss na ako, tapos medyo kung hindi ako comfortable dun sa definition or may gusto akong ibang sabihin dun sa definition, nilalagay ko siya on the spot. Tapos ang ginagawa ko after the class, ini-edit ko yung LaTeX file. So, yung copy nyo ngayon which I guess is this one, okay, the copy that you have, the same copy that that I'm using right now. Ito yung edited version na. So siguro yung first time na ginamit ko yung lecture notes, doon ko pa lang siya inedit. Pero I guarantee you that the essence are the same. Medyo iba lang yung mga notations, tapos medyo nilipat-lipat ko lang yung mga pagkaka-define. Okay? But nevertheless, they should be similar. So I guess there's a typo here. A point A, little a, an element that is an element of O, is an interior point of the set O, even only if there exists an epsilon neighborhood, okay, around A that is a subset of O. So halimbawa, mas madali siyang i-visualize sa 2 dimensions, okay? So halimbawa, ito yung set O. Yan yung set O. Ang isang element A na nasa loob ni O ay isang interior point. So, ano bang ibig sabihin in layman's term ng interior? Interior dapat nasa loob. Okay? So, interior nasa loob. Paano natin i-guarantee mathematically na nasa loob talaga ni set O si little a? Right? Sabi ng definition, madali lang yan. Dapat makahanap ka ng epsilon neighborhood centered at A that is properly contained in O. Or in other words, that is a proper subset of the set O. So, laging interior point sila kapag makakapag-drawing ka ng neighborhood around A na entirely enclosed dun sa set O. So, this little illustration here, an interior point of the set O. Alright? Now, hindi posible na ang isang set na wala ang isang element na wala kay O ay maging interior point. It doesn't make sense, right? Sabi natin pag interior point dapat nasa loob intuitively, right? So kung nasa labas ka ni set A o na kay O complement ka, diba ito si B, wala nang chance na si B ay maging interior point ni O kasi kahit anong epsilon neighborhood yung i-drawing mo, gaano man kaliit o gaano man kalaki, yung i-drawing mo na epsilon neighborhood around B, wala kang hindi siya proper subset ni O. Alright? Yung open ball na yon o yung epsilon neighborhood na yon ay hindi napapaloob entirely kay set O. So here, any element that is outside of O cannot be an interior point. Okay. Paano naman yung mga nasa boundary? Halimbawa si point C. Ito si point C. Can anyone tell me, is this point probably an interior point or not? What do you think? Si C by interior point o hindi? And briefly explain why. Anyone? Si C by interior point kay O o hindi? Come on, guys. Yes, Prince. Sige, Prince, type mo lang yan if you're still using the chat box. Anyone else while Prince is typing his answer? Anyone who would like to try? Remember, wala namang minus, walang minus kapag mali yung sagot. Yes, Zaira?
Sir, guess lang po. Pero yung e-neighborhood po na nakapalibot po sa CI, hindi po entirely nakapaloob sa O. So, hindi po siya kasamang interior points.
Okay, very good, Zaira. Thank you. Pa-humble pa yan, no? Try lang, hindi sure, pero tama naman yung sagot, right? Because if you try to draw an epsilon neighborhood, sa 2 dimensions ang epsilon neighborhood ay mga circles kasi nga para siyang circle of radius epsilon, right? So you will always get a portion of that circle that is outside, oops, hindi maganda yung pagkakulay ko, that is outside the set O. So hindi siya proper subset ni set O. So kung nandun siya sa boundary, hindi siya pwedeng maging interior point. Kasi nga kahit gaano pa kaliit yung i-drawing mo na epsilon neighborhood, lagi kang may makukuhang members na nasa labas na ni O. Okay? Pero pag meron kang point na super, hindi ko na siya ma-zoom, nandito si D ay interior point pa rin. Kasi ang usapan sa interior point, existence. There should exist an epsilon neighborhood. Hindi niya sinabi na lahat ng epsilon neighborhood dapat nakapaloob kay O. Dapat may makita ka lang na isang epsilon neighborhood, hopefully a small enough epsilon neighborhood that will be entirely contained in the set O. Alright? Tapos, pag kinolekta natin lahat ng mga interior points ni O, makukuha natin yung O interior. Ang notation natin sa O interior ay O upper zero. Okay? Or O upper O. So, ito yung notation natin. So, ang O open O ay yung collection lamang ng lahat ng mga interior points. Okay? And then, our very first major definition from here is that yung pagiging open ng isang set. Kailan natin masasabi ng isang set ay open? Masasabi natin ng isang set ay open kapag laman niya, kapag lahat ng points niya ay interior points. Okay? So kapag lahat ng points niya ay interior points, then it is called an open set. And we denote an open set by this notation. Okay? Parang subset pero may bilog doon sa loob ng subset. So we read this as the set O is an open set in R. Okay? In other words, para maging open siya, dapat ang O ay equal sa interior of O. Okay? Kasi nga lahat dapat ng points na ay interior. Well, open intervals are interior points, are open sets. Kasi pag kumuha ka ng kahit anong point sa open interval, halimbawa kumuha ko dyan ng X, may mahanap ako ng epsilon neighborhood, ganong kaliit na epsilon neighborhood that's properly contained in the open interval. So any point inside the open interval is an interior point. Okay. Pag pumili ako rito ng isang number A na malapit kay A, halimbawa si Y, makakapag-drawing pa rin ako dyan ng isang maliit na epsilon neighborhood na nandun pa rin sa loob ng open interval. So I can do this for all points in the open interval. Sa kahit anong point sa open interval, lagi akong may makikitang isang epsilon neighborhood that is properly contained in the open interval. Kaya nga open interval yung tawag sa kanya. Kasi nga lahat ng points niya ay interior. And these are the easiest examples of open sets, mga open interval. Yung closed interval naman, definitely hindi siya open kasi halimbawa, oops. So ibig sabihin, pag kumuha ko ng isang point dun sa loob ng closed interval, I mean by loob, ibig sabihin, nasa strictly pagitan ni A and B, okay lang kasi may epsilon neighborhood ako makukuha. Pero remember, sa closed interval, kasama si A at saka si B. They are members of the open interval. But if I look at A, no matter how small a neighborhood I draw around A, lagi ako may makukuha mga members na nasa labas ng closed interval. Alright? Kahit paliitin ko pa si epsilon, laging merong mga sasamang members na nasa labas ng closed interval. So that means any epsilon neighborhood around A will definitely contain elements that are not in the closed interval. So definitely A is not an interior point. And since we have found an element of the closed interval that is not an interior point, then we can say that this closed interval is not open. Okay? Is that clear? Though parang na-example ko na to dun sa video, right? Hindi ko mapigilan na i-explain siya. Pero yeah, in a nutshell, that's the concept of open intervals. So by the way, some other examples, the empty set is open. Kasi this is what we call a vacuous result. Okay? Kasi nga ano nga ba ang mga interior points ng empty set? Dahil si empty set ay walang laman, so definitely wala siyang interior points. Dahil wala siyang laman, dahil wala siyang interior point, wala siyang kailangang lamanin. Alright? So kaya siya ay nagiging open set rin. Ang tawag natin vacuously. Alright? Kasi by default, logically, dapat siya ay open. Kasi nga, wala naman siyang dapat laman kasi wala siyang interior point. Kasi in the first place, wala nga siyang laman. So definitely, nasa-satisfy niya yung definition vacuously. Alright? Another thing is R is an open set. Alright? Because if you pick any epsilon neighborhood of a real number, it will always be a subset of the set of real numbers. Okay. And then theorem 1.12 gives us a nice way of creating larger open sets. Kung meron ka ng alam ng mga open sets, and for us, we know a lot of open sets. Kahit anong open interval, mga open sets yung mga yan. Ang sinasabi ng theorem 1.12 part 1, pag kinuha mo yung union ng kahit gaano kadaming open sets, ang sagot, open pa rin. Alright? The union is still open. Now, but if you have a finite collection of open sets and you take their intersection, then what you will get back is another open set. Okay? Which brings up a nice question. Bakit kailangan na finite? So in the proof that you watch, ginamit talaga dun sa proof yung pagiging finite nung collection na kinukunan mo ng intersection. All right? But it would be a nice exercise to find a counterexample na meron kang infinite collection ng open sets na ang intersection ay hindi open. Alright? Since sinasabi ng property 2, kapag ka may finite collection ka, kunin mo yung intersection, ang sagot ay open. Bakit hindi siya nag-hold kapag ka infinite na yung collection? So try to give a counterexample. Think of an infinite collection of open sets na yung intersection niya ay hindi open. Right? So that's a nice, probably it could appear in the problem set or in a future homework. So who knows, all right? So start thinking about that. Let me put a star on it. Okay. Baka malagay ko siya somewhere. Okay. Because this is a nice exercise. Okay. Now, limit points. Now, so meron tayong interior points. Tingnan naman natin yung mga limit points. Ang isang number x ay isang limit point ng isang set. Okay? First thing to note here is that the number x need not be a member of capital A. Remember yung definition ng interior point, nagsimula siya dapat an element A of O is an interior point of O if and only if. Sa definition ng limit point, walang sinabi na yung limit point x ay nasa set A. So, posible na yung mga limit points ay wala dun sa isang particular set A. Right? So, a point is a limit point if and only if what? If and only if every epsilon neighborhood of x intersects the set A in some point other than x. So basically, ang isang point ay nagiging limit point kapag kahit anong epsilon neighborhood for all epsilon greater than 0, okay, there exists a y different from x such that y is a member of the intersection of the epsilon neighborhood and the set A. Yan yung definition naman ng limit point. Limit point siya kapag kinuha mo yung intersection ng kahit anong epsilon neighborhood ni x. Okay? No matter how small that epsilon neighborhood is, you take its intersection with the set A and you find another member different from the set x itself, then you say x is a limit point. Okay? So, mas technical yung pagkakagamit ng limit point. So, ibig sabihin lang sa yung neighborhood ni X, lagi siyang may laman na maraming members ni capital A. Kaya mas gusto kong tinatawag yung limit point as cluster point or accumulation point. Kasi ibig sabihin, kung si X ay limit point, ibig sabihin nagsisiksikan yung mga elements ni capital A dun sa neighborhood ni set X. Alright? So, dahil yun nga, kahit ano pang epsilon daw, o yung ibigay mo, however small it is, yung open ball with radius epsilon centered at x ay may laman na ibang mga members ni capital A. So ibig sabihin, yung mga members ni capital A ay nagkukumpulan. Kaya siya cluster. Nagkukumpulan sila doon sa neighborhood ni x. Because any neighborhood of x, however small it is, it will contain members of capital A aside from x itself. All right? And take note of the quantifier here, every epsilon. So it's a universal quantifier, which is different from interior points. Sa interior point, there exists an epsilon lang. Right? Sa limit point, every epsilon dapat. Okay? And then if we will collect all limit points of a set A, then that's what we call the derived set of capital A. And the notation natin para sa set ng lahat ng mga limit points ni A ay A prime. Okay, so that's the derived set. And I think this is where I ask you to stop watching the recording, the second video in your watching assignment last time. So bago tayo pumunta sa isolated point. So yung isolated point naman, siya yung kabaligtaran ng limit point. Pero tingnan nyo ngayon, ang isang isolated point dapat ay nandun sa set A. So ang isang element ni A ay isang isolated point ni A kapag ka hindi siya limit point. Okay? Kaya siya isolated kasi nag-iisa siya. So ibig sabihin, merong epsilon neighborhood si A na walang laman na iba pang members ni A. So parang nagsosolo siya. So makakakita ka ng isang epsilon neighborhood kahit maliit, makakita ka lang ng isa na epsilon neighborhood such that wala siyang kasamang ibang members ni capital A. Right? And if that's the case, then we say that that member little a of capital A is an isolated point of the set A. Okay? Now, tingnan natin yung example 1.4, and I think this is better seen via an illustration. Okay? Ito yung real number line. Ang set na i-consider natin ngayon ay set ng mga 1 over n's such that n is a natural number. So we'll begin with n equals 1. So C1, member siya ng set. Tapos, when n is equal to 2, we'll get 1 half. Diba? Ito si 1 half. Okay. Lagyan natin si 0 dyan. Oops. Huwag ko na nga ilagay yung 0. Figure not to scale na lang. So, ito si 1 half. Okay. Member din siya ng set. N equals 3, si 1/3. So, halimbawa, nandito si 1/3. Tapos 1/4. Oops. Sorry, hindi ako makapagbura na. So, figure not to scale na lang. And then si 1/5, si 1/6, si 1/7, and so on. Alright? Yan yung mga members ng set. Okay, ang sabi dito, ng example na to, lahat daw ng mga points ni A ay isolated. Ibig sabihin, hindi dapat sila limit point. Sabi ng pagiging limit point, lahat ng epsilon neighborhood dapat may member ng given set. Alright? Kasi yung intersection niya with the given set must be non-empty. Dapat may laman siya other than the number itself. However, look at 1. 1 is an element of capital A, so it's a candidate to be an isolated point. Then the question is, can we prove or can we argue that 1 is not a limit point? Meron bang epsilon neighborhood C1 na walang laman na ibang members ni capital A? Kasi nga dapat hindi siya limit point. Not a limit point. Eh, ang pagiging limit point for all epsilon, negation. So Math 101, negation of for all there exists. So can we find an epsilon greater than 0 such that the epsilon neighborhood around 1, okay, doesn't intersect the set A aside from the number 1 itself? Okay? So, can anybody give me a nice epsilon para kay 1? Para ma-prove ko na siya ay isolated. Bigyan nyo nga ako ng epsilon neighborhood or a value for epsilon na yung epsilon neighborhood around 1 intersection the set A ay wala nang ibang laman kundi si 1. Anyone? Kasi di ba yun yung kailangan? Para siya ay mapakita na siya ay isolated point, hindi siya limit point. So dapat nagsosolo siya. So kaya kong makakita ng isang epsilon neighborhood kung saan nakakulong doon yung number A, tapos nagsosolo siya doon. Wala siyang ibang kasama na ibang elements ni capital A. Alright? So basically, I can choose my epsilon to be any number that is less than 1 minus 1 half. Kasi ang layo ni 1 dun sa kanyang pinakamalapit na neighbor ay 1 half. So pag pumili ako ng kahit anong number na mas maliit kay 1 minus 1 half, the distance between these two guys, then that epsilon will generate an epsilon neighborhood that will not intersect A in a point other than 1. Okay? So pipiliin ko tong epsilon na to. So this is any epsilon that is less than 1 minus 1/2, but greater than 0. All right? So kahit anong epsilon neighborhood, as long as epsilon is smaller than 1/2, then yung epsilon neighborhood na yon around 1 will not contain any other member of capital A. Kaya si 1, sure ako, isolated point siya. Ganun din si 2, ganun din si 1/2. Si 1/2 member ng set. So posible siya maging isolated point. Para ma-check kung siya ay isolated point, kailangan ko makahanap ng epsilon neighborhood kung saan kaya ko siyang ikulong na nag-iisa siya. Wala siya dapat ibang kasamang elements ni capital A. So, pwede kong piliin yung epsilon neighborhood to be this open interval. Alright? And notice that this open interval doesn't contain any member of capital A aside from 1/2. So, ibig sabihin, nakakita ako ng epsilon neighborhood, specifically an epsilon that any epsilon greater than 0 that is less than 1/2 minus 1/3. Kasi nga, 1/3 yung nearest neighbor ni 1/2. So, pag pinili ko si epsilon to be any number less than 1/2 minus 1/3, so hindi ako aabot dun sa susunod niyang kapitbahay. So, pag pinili ko kasi mas malaking epsilon, so posibleng mahagip si 1/3. So, pipiliin ko si epsilon to be any number smaller than this distance, the distance from 1/2 to its nearest neighbor, to guarantee na yung epsilon neighborhood lang, nag-iisa si 1/2. Wala siyang kapitbahay na ibang members ni capital A. So that means 1/2 is not a limit point because we have found an epsilon kung saan dun sa epsilon neighborhood na yun, walang kapitbahay si 1/2. And you can do this argument for all members of capital A. All right. In particular, if you take an arbitrary 1 over n in capital A, you just choose epsilon according to our analysis earlier. Piliin lang natin si epsilon to be anything smaller than its distance from its nearest neighbor. So kung si 1 over n, ang pinakamalapit ng kapitbahay ay si 1 over n plus 1. Piliin mo lang yung epsilon to be any number less than or equal to this difference, then you are sure that the intersection of the set A and that epsilon neighborhood will only contain the number 1 over n itself. Wala nang ibang laman yung intersection kundi si 1 over n. Ang usapan para maging limit point, dapat may kasama si 1 over n dun sa intersection. Okay? So that shows that this guy, this set, all elements of this set is isolated. Okay. All right. Any questions? Clear ba yun? I was surprised walang gusto humula doon. But is this making sense? Or pagod na kayo kasi Thursday na, patapos na yung linggo? Come on guys, react. Kahit pindutin nyo lang yung react button, masaya na ako doon. Huwag nyo nang ipagkait yung konting kasiyahan ko na nakikita nag-react kayo. Or mabagal lang talaga yung internet ko, hindi ko nakikita yung reactions nyo. But anyway, I hope this is clear. Okay. All right. So yun yung mga isolated points. Now, can we find a limit point of 1 over n? So can we find a real number, not necessarily belonging to A, such that magiging limit point siya nung set A, right? So hanapan naman natin siya ng limit point. So alam natin lahat ng mga laman ni set A ay isolated. So ibig sabihin hindi sila mga limit points, but is there a real number that is a limit point of this set? So ibig sabihin ang tanging candidates na lang natin ay mga real numbers na wala dun sa set A because a limit point is not necessarily a member of the set A itself, all right? So can anybody venture a guess? Sino kaya yung limit point? Or meron pa ba tong limit points? And again, sabi ko nga funny yung mga mathematicians. Bakit niya tinawag to ng limit points? Na-associate natin yung term na limit para sa limit ng sequences at saka sa limit ng isang function. Tapos 1 over n yung itsura ng mga members ng set. So piece those things together, ano yung hula nyo para maging limit point ng set na to? Yes, Lyra?
0 po, sir.
Okay, thank you. That's perfect. 0 is a limit point of this set actually. So, halimbawa, ito si 0. Okay. Now, ano nga ba yung requirement para maging limit point? Dapat lahat ng epsilon neighborhood centered at 0 must contain, okay, must contain a member of the set A. Kung pipiliin ko yung 1 neighborhood, when epsilon is equal to 1, and then ito yung makukuha kong set. Ito yung makukuha kong kalahati ng epsilon neighborhood centered at 0 with radius 1. Definitely, marami siyang laman ng mga members ng set A. Kaya lang ang sabi ng definition ng pagiging limit point, this should be done for all epsilon greater than 0 no matter how small it is. Now, if I make my epsilon smaller, okay, halimbawa epsilon is 1/2, is the epsilon neighborhood centered at 0 with radius 1/2 contain elements of the set A aside from 0. But basically, 0 is not an element of A. So, pwede nating tingnan non-empty na lang ba yung intersection. Well, if epsilon is 1/2, this is half of the epsilon neighborhood. Yung kalahati siya yung nandito sa negative numbers, pero wala naman tayo doon makukuha ang ka-intersection with A. But the right half of the epsilon neighborhood or the 1/2 neighborhood of 0, ang dami niyang laman ng mga members ng set A na hindi equal kay 0. Okay? Now, if I will select any other real number, if I say 10 to the minus 8, may makikita pa ba ako na epsilon, meron pa ba makikitang member ni 1 over n, nung set containing numbers of the form 1 over n, na nandun siya sa loob ng epsilon neighborhood centered at 0. So, and again, the thing that I can use here is the Archimedean principle. Okay? So, magsimula ka sa isang epsilon na masyado nang maliit. So, let's take an arbitrary epsilon greater than 0. Then, by the Archimedean principle, isa sa mga consequences ng completeness, there exists a natural number little n in n such that ang 1 over n ay less than epsilon. Okay? So, ito yung sinasabi ng Archimedean principle. Kahit gaano pa kaliit si epsilon, lagi kang may makikitang natural number na ang 1 over n ay mas maliit pa rin dun sa epsilon. Pero anong ibig sabihin ng 1 over n being less than epsilon? This means that 1 over n is a member of 0 minus epsilon until 0 plus epsilon. Okay? But this open interval here is basically the epsilon neighborhood centered at 0. Okay? So here we have found na kahit ano pang epsilon yung ibigay ko sa inyo, lagi tayong may makikitang 1 over n na nandun sa epsilon neighborhood centered at 0 with radius epsilon. So yung intersection nung epsilon neighborhood centered at 0 and the set A itself will not be empty. Lagi siyang magkakaroon ng laman, specifically si 1 over n, okay, na hindi equal kay 0. So indeed, si 0 ay isang limit point talaga ng set 1 over n. Or in layman's terms, ang nangyayari dyan, kapag nag-drawing ako ng isang epsilon neighborhood around kay 0, itong epsilon neighborhood na to ay guaranteed na may mga laman ng mga members ng set A. So dito may makikita ko dyang mga numbers ng itsura ay 1 over n, where n is a natural number. And I can do this even if I shrink epsilon down to the tiniest bit. Kahit palitin ko pa ng palitin si epsilon, lagi akong may makikita na 1 over n na mas maliit kay epsilon. At yung 1 over n na yon, dahil mas maliit siya kay epsilon, ang distansya ng 1 over n na yon mula kay 0 ay mas maliit kaysa kay epsilon. Alright? Okay? So, questions with that? Okay. So if there are none, then let's look at the next example. Tingnan naman natin yung closed interval. The closed interval AB, which contains all numbers between A and B included. Okay. So, makikita natin na lahat ng mga elements ng closed interval AB ay mga limit points. Okay? So, let's start our analysis with elements of the open interval. Okay? AB. So, tingnan natin. So, ito yung closed interval AB. Kapag ka ba strictly between A and B ako, limit point pa rin ba yung makukuha ko? So, kumuha ko dito ng isang element X na strictly nasa pagitan ni A and B. Now, pag nag-drawing ako ng epsilon neighborhood, however small that epsilon neighborhood is, yung epsilon neighborhood na yon, magkakaroon siya ng laman ng closed interval AB other than X. Specifically, the numbers that are here. Okay? Kasi nga yung X plus epsilon ay element ng closed interval AB. So yung open interval X minus epsilon hanggang X plus epsilon ay laging magiging member ng closed interval AB if epsilon is less than the length of AB. So kung palakihin ko man yung epsilon neighborhood, kasi ang idea, bakit sir maliliit lang ng mga epsilon neighborhood yung kinoconsider mo? Well, kasi kung papalakihin ko yung epsilon neighborhood, kung halimbawa ito yung epsilon neighborhood na i-consider ko, okay, malaki yung epsilon neighborhood, okay, mas marami siyang laman na elements ng closed interval. Alright? Kasi ang kailangan ko lang naman, dapat magkaroon siya ng at least isang laman nung set other than the limit point itself. Alright? So, nakita natin dito na kapag kasi X ay interior dun sa closed interval, mag-drawing lang ako ng epsilon such that X minus epsilon, comma X plus epsilon is within the interval AB, then we are sure that that will have a non-empty intersection with a closed interval AB. And even more than that, that intersection contains another member aside from X itself. Okay? So lahat ng mga strictly nasa pagitan ni A and B ay mga limit points ng isang closed interval AB. Now, the more interesting numbers here are the boundaries itself. Si A at saka si B ba ay mga limit points? Well, tingnan natin. Pag nag-drawing ba ako ng epsilon neighborhood, gaano man kaliit, meron pa rin bang member ng closed interval AB ron maliban kay A? The answer is yes. Because epsilon is greater than 0, if you draw any epsilon neighborhood around A, lagi kang may matatouch na members ng closed interval. Kasi yung 1 plus epsilon for small enough epsilons will still be less than B. All right? And then that A plus epsilon will definitely be a member of the closed interval AB. So kung maliit si epsilon, then A plus epsilon ay member ng closed interval AB. So yung intersection ng open ng epsilon neighborhood centered at A together with the closed interval AB. So this intersection will contain members other than A. Specifically, laman niya yung mga numbers of the form 1 plus epsilon. Alright? Now, kung malaki yung napili mo na epsilon, edi mas maganda. Kasi pag malaki yung napili mo na epsilon, halimbawa, ito yung napili mo na epsilon, ito yung epsilon. So, definitely, yung epsilon neighborhood around A will contain the entire interval AB. Eh, ang usapan lamang sa pagiging limit point, dapat magkaroon ka lang ng at least isa pang member ng intersection aside from the number itself. Alright? So, you will see here na, nag-accumulate o nagka-cluster, nagkukumpul-kumpul yung mga elements ng closed interval AB around A. Right? Kasi nga dito, napakaraming members ni closed interval AB na naninirahan sa kanan ni A. It doesn't matter kung walang laman dito sa kaliwa. Alright? Kasi ang sabi dapat yung intersection. Dito pa lang, dun sa kanang half pa lang nung open anong epsilon neighborhood around A, marami na tayong makukuhang members ng closed interval. Okay? And the same thing, the same analysis will hold true for the set for the number B. So we can conclude that really B is a limit point of the closed interval AB. So essentially, ang derived set pala ng closed interval AB ay equals sa closed interval AB. Kasi laman niya na lahat ng kanyang mga limit points. Na-define ko na nga ba yun? Okay. What do you think about what is the derived set of the open interval AB? Sige nga, anybody? Kukolektahin nyo lahat ng limit points ng open interval A. Anyone? Ano yung derived set ng open?
Sir, medyo choppy po kayo.
Mga points. So sige, drawing ulit. So open. Pag kumuha ko isang random
Sir, nadi-disconnect po ata kaya.
ko siya, halimbawa, yeah, hello. I'm back na po ako doon. Yeah. Trying to illustrate ano yung nangyayari. Ano yung okay. Sorry, nagloloko na naman yung internet ko. So, but huh. Okay. So, pag nag-drawing ako ng open interval AB on the real number line, yeah, sorry guys, na-disconnect ulit ako. Let me try to reconnect again. Alright, meron ba nag-attempt kanina na sumagot kung ano yung derived set ng open interval AB? Wala ba nag-attempt? Baka na-miss ko lang kasi hindi nag-update sa akin yung mga reactions. But anyway, the derived set of the open interval AB is actually the closed interval AB. So 'di ba sa derived set, kailangan lang nating kolektahin lahat ng mga limit points. Now tingnan natin, yung interior ba ng open, yung mga interior points ba ng open interval AB ay mga limit points? Well, if you consider an interior point X of the open interval AB, you draw a small epsilon neighborhood around it, then you will see that that epsilon neighborhood contains members of open interval. All right? So dahil marami diyang mga open intervals na laman, yung B sub epsilon of X, yung epsilon neighborhood centered at X. So marami siyang laman na elements ng open interval AB aside from X itself. So that makes X an interior, a limit point. Okay? Dahil arbitrary si X ay isang arbitrary interior point ni X. So lahat pala ng mga numbers na nandun sa loob nung open interval AB ay mga limit points. Alright? Pero hindi lahat ng limit points ay nasa loob ng open interval AB. Okay? Kasi halimbawa, si little a, wala siya dun sa open interval AB, pero pag nag-drawing ka ng epsilon neighborhood centered at A, dun sa kanan na bahagi nung open interval na yon o ng epsilon neighborhood na yon, lagi yung may mga members ng open interval AB. So that means the intersection of any epsilon neighborhood centered at A together with the open interval AB will contain members other than the number A. So meron tong laman. So actually, this would be non-empty. Okay. Meron siyang laman ng mga members ng open interval aside from the number A. Pero hindi nakasali si A sa bilangan kasi nga si A wala naman siya dun sa open interval. Okay? And the same thing will happen for the number B. Si B rin ay isa ring limit point. Kasi nga pag nag-drawing ka ng epsilon neighborhood around B, gaano man kaliit yung epsilon neighborhood na yon, lagi tayong may makikitang elements ng open interval AB. Okay? Ayan, ngayon ko pala nakita yung mga comments. Sorry about that. Kanina pa pala ako nagcha-choppy. All right. So, yun yung parang visual analysis. Yeah. So, that's the visual analysis kung paano makita kung siya ay limit point o hindi. Yung analytical o yung formal proof of showing that a certain number is a limit point of a set, makikita natin siya dun sa mga proofs natin later. Okay? Now, let's go to definition 12. Okay? So sa definition 12 naman, i-define natin, actually, hindi pa pala 12. Definition 11 muna. Sa definition 11, dinidefine natin hold on lang guys. Gagamitin ko na nga yung mobile data ko. Hold on. And hopefully, mas okay to. Nag-switch na ako sa mobile data. Let's see. Okay, lipat ko lang yung tablet ko sa mobile data rin. Hopefully, this is better. Yeah, kaya nagkikip ako lagi ng mga backups pagka ayaw nung internet sa bahay, so mobile data tayo. Let's see, it's loading a little bit. So can you guys see my screen now? Sana hindi ganun din yung kalabasan.
Hindi pa po, sir.
Alright, so let's see. May nangyari. So ito na yung wellness break natin. So hinga muna kayo ng konti. Uh, hmm. Bakit kaya siya na-stuck? Hindi ko pa rin nakikita yung share screen though. On my tablet, naka-screen share na siya. Mhm. Sige, CR break muna kayo. Meron pa naman tayong 13 minutes. All right, finally. So hopefully this now works. Okay, so I hope kita nyo na yung screen. So we are about to define what a closed set is. So alam na natin yung open set. Yes, Ira?
Sir, namali lang po ng
Baka,
pindot sa
yes, yan. Okay, no problem. All right, so we are about to define what a closed set is. Sabi natin open set siya kapag lahat ng points niya ay interior. So ibig sabihin sa lahat ng points niya laging may epsilon neighborhood na properly contained sa kanya. Now, what does it take for a set to be closed? Well, a set F is closed, right? Written this way. So, sulat natin yung pagiging closed ng isang set this way. Parang subset na yung bar ay nandun sa taas. So, F is a closed set in R if it contains all of its limit points. So, dapat laman ni F lahat ng mga limit points niya. Okay? So, kung laman niya lahat ng mga limit points niya, then siya ay isang closed set. Or in other words, if the derived set of F is properly contained in F. Lahat ng limit points niya dapat laman niya. Okay? So quick examples, the closed interval is a closed set because we said na lahat ng mga limit points ni closed interval AB ay actually mga elements ng closed interval AB. So kaya siya ay isang closed set, and that's not hard to reconcile with the terminology that we had been using since we met algebra, right? Noon pa lang tawag na natin ay closed interval. Kaya pala siya closed interval kasi siya yung pinakamadaling example ng isang closed set. Okay? Now, a non-example is the set of rationals. The set of rationals is not a closed set. Kasi meron siyang mga limit points na doon sa wala doon sa set of rational numbers, right? So halimbawa, si square root of 2 is a limit point of Q. But square root of 2 is not a member of Q. So meron tayong nakitang isang limit point ni Q na hindi naman niya miyembro. So bakit siya totoo? Kasi pag nag-drawing ka ng open interval around kay square root of 2, nag-drawing ka ng epsilon neighborhood. Okay? Sabihin natin yan yung epsilon neighborhood mo. Around epsilon over 2. Then that means maraming mga rational numbers sa interval na yan. Bakit maraming rational numbers sa pagitan sa epsilon neighborhood na yan? Can anyone explain or venture a guess? Bakit ko, kasi gusto kong ipaliwanag na si square root of 2 ay isang limit point ni Q. Pero si square root of 2 kasi ay irrational. So that lead us to conclude that Q is not a closed set. Kasi meron siyang isang limit point na wala dun sa set na ito. Or wala sa kanya. So bakit si square root of 2 ay naging limit point? Can anybody justify that? Kasi pag na-explain na natin na si square root of 2 talaga ay isang limit point, okay? So automatic, hindi na talaga close si Q. Yes, Ayesa?
So dahil po dun ba sa density property of Q and R, parang lagi pong may rational number in between two real numbers. So makakahanap po tayo ng rational number dun po sa epsilon neighborhood po ng square root of 2.
All right, perfect. Ayesa is right. Tama, yung paggamit ng density property kasi sa pagitan ni square root of 2 minus epsilon, which is this guy, and square root of 2 plus epsilon, which is this guy, sabi ng density property, merong rational number sa pagitan nila. All right? So ibig sabihin, may rational number dito sa yellow interval. And I can make epsilon very, very small, and yet the density property of Q and R will justify the existence of a rational number in that very, very small epsilon neighborhood. So ibig sabihin, indeed, square root of 2 is a limit point of Q. Pero alam natin, wala siya kay Q. So nakakita tayo ng isang limit point ni Q na wala kay Q, so si Q ay hindi closed. All right? Okay, and then, so those are some quick examples. Then gusto ko lang daanan itong definition ng closure. Okay? Tapos dito tayo magtatapos sa number 4. I was hoping to finish the entire module, but again, my internet connection did not cooperate. So, but that's fine. Okay? We can take our time. So tapusin lang natin tong closure. Buti pa yung set of real numbers may closure, no? So essentially, what is the closure of a set? Now, the closure of a set is denoted by A bar. So marami na tayong symbols na nakilala ngayon. Si AO, interior point, set of all interior points of A, or the interior of A. A prime, the derived set of A, which is basically the set of all limit points of the set A. And then now we're introducing A bar, or the closure of A. Ano naman yung closure ng isang set A? Yung closure ni set A ay yung union lamang ng set itself at saka ng mga limit points niya. So pagka isinama ko sa isang set, lahat ng mga limit points niya, because remember, limit points might reside or they might live outside of the set. Hindi kailangan yung limit point nasa loob ng given set. So pag sinama mo dun sa set A, lahat ng mga limit points niya, ang makukuha natin ay yung closure ni A. Okay? So going back to our examples earlier, remember the set A containing numbers of the form 1 over n. Okay? Ang closure ng A, or A bar, is the set A itself, union, the set of all limit points of A. But 0 is the only limit point of A. So itong set na to, A union 0, is the closure of the set A. All right? And then, tingnan natin ito. So, ano yung closure ni Q? Remember, the closure of Q will be Q union Q prime. All right? So kunin mo lahat ng rationals, isama mo sa kanya lahat ng kanyang mga limit points. Okay? But it can be argued na lahat ng mga irrational numbers ay limit points ni Q. Or actually, pwede mo sabihin hindi lang rationals. Hindi lang irrationals sa mga limit points ni Q. Actually, lahat ng real numbers ay limit points ni Q. Bakit? Kasi pag kumuha ka ng isang real number, all right? Kumuha ka ng epsilon neighborhood around that real number R. So R is an arbitrary real number. It can be rational, it can be irrational, so it doesn't matter. So gusto ko kasing ipakita na ang derived set ni Q ay R. Ang Q prime ay equal kay R. Kasi pag kumuha ko ng kahit anong real number, say little r, okay, kukunin ko yung epsilon neighborhood, however small the epsilon is. So makakuha ko ng r minus epsilon, saka r plus epsilon. Alright? Sa pagitan ni r minus epsilon at saka ni r plus epsilon, because these two are real numbers, may makikita akong isang rational number by the density property of r. So that means Q prime is really R. So the derived set ng rationals ay si R. So this means this is Q union R, which is equal to R. So ang closure ng set of rational numbers ay si R din. And the same thing goes for the irrational numbers. Q complement bar, or the closure of Q complement, is also R. And then it's easy to see that the closure of an open interval is the closed interval. Okay? And if A is already closed, kung siya ay closed, ano yung definition ng closed? Laman niya na lahat ng kanyang mga limit points. So ibig sabihin yung closure ni A, which is defined to be A union A prime, pero sabi natin closed si A. Actually, hindi lang ito nag-hold sa closed interval. So sa kahit anong closed set, ang A bar ay equal pa rin kay A. Bakit? Kasi by definition, si A bar, closure of A, is the set union its limit points, or the set of all of its limit points. So A union derived set ni A. Pero sabi natin si A ay closed. So ibig sabihin, si A prime ay equal kay A. Kasi laman na ni A, hindi pala A prime equals A. So si A prime ay subset ni A. Kasi lahat ng limit points ni A ay nakapaloob na kay capital A. So that means this will just become A itself, because A prime is a subset of A. A union, any of its subsets, will give us A. Alright? So kaya kapag ka-close na yung isang set, alam mo na laman niya na lahat ng limit points niya, so wala ka nang idadagdag sa kanya. Kasi yung derived set niya ay subset na nung sarili niya. So definitely there is no other element to be added to get the closure of the set A. Right? And the closure has a very interesting property, and that's in theorem 13. So ang sabi nito, si A bar ay isang closed set. Okay? So ang closure ng isang set for sure ay closed. And it is not just that. It is a very special closed set because it is the smallest closed set containing capital A. And we will start our next meeting by proving theorem 1.13. Okay? And then I think after that, we'll prove 1.14. And then ililive ko na lang as an exercise yung 1.15. And then a bunch of 3 other definitions, and we're done with chapter 1. Okay? So since we're done with chapter 1, probably we will have the first problem set middle of next week. So siguro ibibigay ko na lang siya ng Thursday para magawa niyo siya ng Friday, and then Monday, and then Tuesday. Gagawin kong Wednesday na lang yung deadline ng problem set. So siguro sulat ko rito, PS1 to be given, kailan yan sabi ko, Thursday next week. Tapos ang submission probably ay gawin nating Wednesday next week. All right? So Wednesday, week after next. All right? Pero according to sa calendar natin, meron pa tayong homework na magiging due sa Monday. So later tonight, I will upload in Canvas a short homework, probably about computing closures, computing the derived set, interior points, and so on. So you will just play around with the definitions, okay? Bibigyan ko kayo ng mga specific sets. So bibigay ko siya mamaya. Ang deadline niya ay Monday, right before midnight, okay? So yun yung gagawin nyo next week. Tapos sa Thursday next week, ibibigay ko yung problem set 1. And then yung submission ng problem set number 1 will be Wednesday, week after next. Tapos wala tayong homework next week. Kasi magpa-problem set nga kayo. So, hindi natin pagsasabayan yung submission. Okay? So, on next week, homework number 3 will be due. And then week after next, problem set number 1 will be due. The coverage will be on unit 1. Okay? So, other questions? Kala ko matatapos ko na ngayon yung lecture note 1 or yung unit 1. Kaya lang hindi nakasama si internet. So I hope you guys pick up something today. So let's just meet on Tuesday again. But until then, keep safe and yeah, enjoy doing maths. So bye guys. See you on Tuesday.
Thank you po, sir. Ingat po.
Thank you po.